Thermodynamics tells us the direction of their reaction, but says nothing about the speed. Kinetics focuses on the pathway between the reactants and the products. Thermodynamics focuses on the initial and final states. First law of thermodynamics: energy cannot be created or destroyed, therefore, the total energy of the universe is a constant. Energy can, however, be converted from one form to another or transferred from a system to the surroundings or vice versa. Spontaneous processes are those that can proceed without any intervention. Processes that are spontaneous in one direction are non-spontaneous in the reverse direction. Examples of spontaneity: ball rolling down a hill, gas filling its container uniformly, heat flowing from hot to cool. Object, temp below 0 C, freezing and ice melting above 0 C. Processes that are spontaneous at one temperature may be non-spontaneous at other temperatures. Spontaneous processes are irreversible. In a reversible process, the system changes in such a way that the system and surrounding can be put back in original state by exactly reversing the process. Entropy can be viewed as a measure of randomness or disorder. Entropy is related to the various modes of motion in molecules. The driving force for a spontaneous process is an increase in the entropy of the universe. For a process occurring at constant temperature, the change in entropy is equal to the heat that would be transferred if the process were reversible divided by the temperature. Delta equals entropy is a thermodynamic function that describes the number of arrangements that are available to a system existing in a given state. Ludwig Boltzmann described the concept of entropy on the molecular level. Temperature is a measure of the average kinetic energy of the molecules in a sample. The number of microstates and, therefore, the entropy tends to increase with increases in temperature, volume and the number of independently moving molecules. Entropy increases as the number of possible arrangements increase. Entropy increases from a solid to a liquid to a gas. Entropy increases as the number of atoms in a molecule increases. Entropy increases as the ions in a crystal lattice are solvated. Second law of thermodynamics. In any spontaneous process there is always an increase in the entropy in the universe. Third law of thermodynamics. The entropy of a pure crystalline substance at absolute zero is zero. Standard entropies tend to increase with increasing molar mass. Larger and more complex molecules have greater entropies. If heat flows from the system into the surroundings, delta S of the surroundings is greater than zero. If heat flows into the system from the surroundings, delta S of the surroundings is less than zero. The magnitude of delta S of the surroundings depends on temperature. The sign of delta S of the surroundings depends on the direction of heat flow. G is called the Gibbs free energy. A process will be spontaneous at constant temperature and pressure only if delta G is less than zero. Delta G being less than zero is equivalent to saying delta S of the universe is greater than zero. If delta G is negative, the forward reaction is spontaneous. If delta G is zero, the system is at equilibrium. If delta G is positive, the reaction is spontaneous in the reverse direction. If delta S is greater than zero, and delta H is less than zero, delta G is less than zero and is spontaneous at all temps. If delta S is greater than zero, and delta H is greater than zero, delta G is less than zero, only if the temperature is high. If delta S is less than zero, and delta H is less than zero, delta G is less than zero, only if the temp is low. if delta S is less than 0, and delta H is greater than 0. Delta G is greater than 0 and is not spontaneous at any temperature. A pure element is in the physical form that is thermodynamically most stable at 1 atmosphere and 25 C. A solid or liquid compound is pure. A gaseous compound is at 1.00 atmospheres of pressure. A solute has a concentration of 1.00 m.